Eric Burgess here, and today we've been asked to find the area between z equals 0 and z equals 2. So in another video, we talked about finding the area on the left or the right, but this time we've been confronted with finding the area in between two z-scores. So recall again, since it's a z-score, we're using the standard normal distribution, and the standard normal distribution always has a mean of 0 and a standard deviation of 1. Now, the first step to always do these kinds of problems is to first draw a normal curve. So we go ahead, we just come down here, we draw ourselves a beautiful looking normal curve. And in the middle is the mean, which in our case, since it's a z-score, we know that it's going to be 0 and its standard deviation will be 1. That's just how far we move. So we should graph our two z-scores. So our first z-score is right here at 0, so it's in the center. And then over here is 2. And so we now recall going this way, this would be -2. So that's why we're going that way. I've seen that mistake sometimes. So all right, what we need to do now is draw a line at our two z-scores. So we have one at 0 and we have one at 2. Now a z-score of 0 is really easy to deal with because we know that the area to the left of this guy, so this is the area to the left, right? The area is the space between the curve and this line. So here's the curve, this is the line. And so we call this AL, area to the left. And so we know that since this is halfway, this has to be 0.5 because that's 1/2. And 0.5 of the area is on this side. Now we're going to do this doing it three ways. We're going to do it using a chart, using a calculator, and using Excel. So this fact is something textbooks and sometimes on tests, teachers like to try and throw you around by throwing out some weird way of asking the question and utilizing the fact that on zero's in the middle, so half of the curve is on this side. So I'm just pointing that out here because you will probably run into it. Let's start with the calculator because that's the way most students are doing it right now. Now we want the area in between. In between is the key word here. So there's between. So that would be this area right here, right? This is between 2 and 0. 2 and 0 is between them. And so what we want is we want this area. So on our calculator, it's going to ask for a lower bound and an upper bound. Well, our lower bound, the lowest point that we're starting at is right here. That's the lower point. And this is the upper point. This is the point where we're ending. So this is the upper bound. So if we go ahead, grab our calculator, we're going to go ahead and turn it on. And now we need, let's clear all this out. We need the distribution because the distribution is what we're dealing with here. So this is in blue distribution. So we hit the blue button, then hit distribution. And then we want the cumulative density function. That's going to be the function that tells us what the area is. It's going to add all the points up. Remember, we want to accumulate all of this. We want to get the entire area. So we hit 2, or you can just hit go down and hit enter. And now our lower bound, well, that's just 0. So that's 0. Our upper bound is 2. And then because we're dealing with z-scores, that's a standard normal distribution, which always has a mean of 0 and a standard deviation of 1. So we've got a mean of 0, standard deviation of 1. We're going to go ahead and hit paste and enter. And this is the area that we get. So this area is the probability that z is between 0 and 2. Now we have to write that in math terms. We can't just write this number. It's just we got to tell it what this number is. So we would write this. So we'd say the probability. So we'd write P for probability and then parentheses. Give yourself some room here. And so Z is in between two things. And the way we write in between in math is we write two greater than signs. And that just is saying that Z is always going to be bigger than something and Z is always going to be less than something. So this is effectively how we say Z is in the middle. So we say Z is in between 0 and 2. It's always bigger than 0, but it's always less than 2. And we found this probability to be, and we're going to use 4 decimal places, 0.4772. And so this would be how we would write our answer. This would be like the really nice formal way. Your teacher may not care as much about the writing it out super fancy. They may just want to see the number. Other teachers are going to want to see this proper formatting really just displays you kind of know what the number means and what it is. All right, so let's go ahead. Let's do the chart method now. So the chart method, we have to do a bit more thinking in order to use the chart, because the chart has a special rule, and you have to keep this rule in mind. Chart always gives area to left. Always gives area to the left. This is incredibly important. If you forget this fact, it's going to be confusing. So, all right. It always gives us the area to the left. So what does that mean? Well, that means if we go into the chart, there's actually a shortcut we could do on this one with the fact that one of our z-scores is 0. But if we go into the chart and look up 0, one of our z-scores here, the number it's going to give us is going to go with this area, the area to the left. And if we look up in the chart, let's draw another normal curve. We'll make this one smaller. We'll put it underneath. Here's the middle. If we put 2 down and look up this one, it's going to give us this area. And so in the chart, what do we want? Well, we want the area. Let's try and line these things up a bit, just a touch. There we go. We want the area in between, right? So if I were to draw a line and sort of shade it in here in red, this is the area that we want. So what we could do is if we take this green area, this green stuff, and we take away the red stuff where they overlap, so it's basically like this. So we've got 2 over here, and it's got all of this. Well, we want to take away this area. We don't want that area because we only are interested in the area in between. So if we take off this highlighted red portion, we'll only be left with this stuff over here. So that's the name of the game with the chart. So the general way we do this using a chart, let's come over here and write it out. And I'll move the calculator out of the way first. The general way we do this with the chart is we take the larger area value. And I specifically say area value because I see people accidentally put z-scores here. So they would do something like 2 minus 0, and then they'd say, oh, the answer is 2. And that's not true. Z-scores are specifically go on the axis down here. They're these guys, and they are not areas, they are not probabilities. And so we have to use the value from the chart because we're interested in this gap between the height of the curve and this axis, this line down here at the bottom. And so I really want to emphasize you need the area. So, okay, we're going to take the larger area value, and then we're going to take off the lower area value. Lower area value. So to do that, we need to look up the z-score for 0, and we need to look up the z-score for 2. Now 2 is the larger area value, right? Because we saw that it covered more area. So 2 is the larger one, and you can pretty much just chalk it up to the bigger number. So let's go ahead and do that. So we'll go to our standard normal tables, and we're going to go to a z-score of 2. Now, keep in mind, this is really 2.00. We don't write the zeros because it's kind of redundant. But there's a 0, 0 column here, and there's a 2 column here. So this is the area that corresponds with it. So that's 0.97725. So we come over here, and we say 0.97725. That is the area. Now we're going to look up the lower area. And in the lower area, let's go ahead and look that one up. That's a z-score of 0. Now on the chart, 0, and then it's 0.00 because there's no numbers after it. So you can just put 2 zeros there. So that's going to be right here, 0, 0, 0. I did that backwards, but you get the idea. All 0. which is 0.5. And this makes sense, right? Because 0 is in the middle, so half of the curve is to the left of it. So we could actually just intuitively look at it and notice that it's 0.5 like we noticed earlier. So if we do this, we're going to get 0.4 and then 7725, because 9 minus 5 is 4, and then the rest are all zeros on this number, so these numbers stay the same. And you should have an answer incredibly close to this. And we notice that we get the same thing. One has just been chopped off here. And so that is how we do it using the chart. Now there's one more way we could do it. We could do it using Excel. And in Excel, it's a very, very similar procedure to actually what we have right here. Lower area value, and then we're going to take that off of the larger area value. So larger minus lower. So let's go ahead. Let's go to the chart. Let's go to Excel. So here's Excel. And this is just a brand new chart. So if you just open up a new document, go to a new chart, you should have something like this. And in the first cell, we're just going to type equals. And we're going to use the same function we did before. We're going to use the standard. We're going to use the normal dot distribution, or a dist, normal dist, all caps. And it says X. So here we see what it wants. It says X for the first, but since our mean is 0 and our standard deviation is 1, that basically turns this X to a Z. So you can kind of imagine this as a Z. So a Z is really just a specific case of X. So what we're going to do is we're going to type in our first one. So our larger value is 2. And then our mean is 0. Standard deviation is 1 because we're on a standard normal distribution. And we want cumulative to be true. And the way you write true is 1. If you want to write false, you write 0. We want true because we want to accumulate all the area under the curve. And then we're going to subtract off from that the normal distribution, because this works like the chart. It gives us the area to the left. And we're going to take away the lower area. So that's the same function, except for this time our Z value will be 0. Our standard deviation, well, our mean is 0, standard deviation is 1, and our cumulative will be true. If we hit enter, we get the same thing. And so we've seen a variety of ways to get the same answer. Now you should have an answer incredibly close to this. It might not be exactly this. It might be rounded 0.4773. You saw in one I left it as 2. It just depends on the method you kind of use, and that will give you like different results. So let's go ahead and jump in. I may have also just not rounded on the calculator. In fact, let's check that. Come back here to our calculator, turn it on. Yeah, no, see, if we do it using the calculator method, it's going to give us a 4 here. And so this is how we would get the answer. So it's just a different method, but the answers are incredibly close. Let's go ahead and do the next one. The next one actually has a little bit of a special property to it, and that's that it's symmetric. And that would allow us to invoke a prior knowledge, but I don't know if you've learned that yet. So we're going to go ahead and do it the same way, because the same way will work. But we can actually look at this and say it's 1 standard deviation away. And we know that according to the standard normal curve, this is going to be 68%-ish. And you'll see that here in just a sec. So what we're going to do is first, step 1, we always draw the curve. So we come down here and we draw the curve. Just sing a little song while you draw it. And then in the middle, we have 0. On one side, we've got -1. And on the other side, we've got 1. Try and make it like somewhat looking symmetric. So we're going to draw 2 lines, and then we shade in the middle. This is the stuff that we want, right? We want the area in between. So we say, okay, area in between, and we want whatever this is. So we say, okay, let's go ahead and use the calculator first. The calculator is super easy. We identify our lower bound and our upper bound. And we simply come, and we want distribution since we're dealing with a distribution. So we hit second to get to the distribution menu here in blue. And then we want the cumulative distribution. We could just hit 2, or we could push down and enter. And we want lower. That is -1. Keep in mind we have to use the special minus key on this calculator. The negative, or this is the special negative key, I should say. The minus sign over here is not the same. This is like only for subtracting. On other calculators, you could use it for both, but not on this one. So we're going to hit the minus key, -1, come down, we're going to enter 1, and then we've got the mean and standard deviation. We're going to hit paste, enter again, and we get, look at that, 68%. What? That's crazy. Didn't I just say that? That's so amazing. So let's go ahead and write that out. So again, we're writing that the probability, and then, because remember, this isn't just any old number. This is a probability. This is the probability that z is in between. So remember, when we write in between, we say something's always less than it and something's always greater than it. And then we say, and I didn't give myself enough room here. Let's give myself some more room. Okay, so let's write down what our lower bound is, which is -1, and our upper bound, which is 0. And this is equal to 0.6827. So this would be our answer using a calculator. Now, if we use the chart, we know that we just do the larger area value minus the smaller area value. So let's go ahead and do that. So we're going to go over to our standard normal tables, and we got our larger area value. Well, that's 1. So here's 1, 0, 0. And that corresponds to this number right here, right? Because if we go down and over, that's where they meet. So that's 0.84134. So we're going to come over here and write that down. We'll do it like right over here to the side. 0.84134. And we're going to take off the lower area value. So that's -1. So we're going to go over to our standard normal. We need to go to the -1 because we have a negative z-score. And remember, -1 is -1.00. That's what we're looking for. So we have -1 down here. And then 0, 0 is the first column. So if we zoom out a bit and we come down and look at it, this is how it would look. So that's the number in question, 0.15866. So we come back and we write 0.15866. And let's go ahead and use the calculator for this one. So 0.84134 minus 0.15866. Hit enter, and look at that. We get the same thing. So we would just go ahead and write, well, in this case, we would write it exactly the same as we've done right here. So it would be the same thing. Our answer, if we did to 4 decimal places for the calculator method, would be 0.6827. So in this case, no rounding difference at all. They would round the same. And finally, let's go to Excel for this. So we're just going to go ahead, pop open an Excel, and let's just write it all out again just because I think it's good practice. So we're going to type equals to let Excel know that we're doing a formula. And then we're going to type our function norm.dist, normal distribution, and it wants our x, so the larger x value is 1. Our mean is going to be 0 because it's a standard normal. Keep in mind we're using z-scores. Our standard deviation is 1, again, because it's a standard normal. And we do want cumulative because we want all the area under the curve. And then we're going to do minus the lower z-score. So that's going to be norm.dist. And then this one's -1. That's our z-score, or in this case, it says x, but it's really our z. And then we have a mean of 0, a standard deviation of 1, and a cumulative is true. So we put a 1 to let it know that, yes, we want cumulative, and we hit enter. And we get 0.682, and this would also round to a 7. And so this is how you do it. So that's that. Pretty straightforward once you understand the formula. The calculator has kind of an advantage when it comes to this sort of a way. And but as long as you know this formula, you have a great way of checking your answer. Very easy to do all 3 methods extremely quickly. So on a test, you should be able to knock it out a couple different ways and verify that you have the right answer. If you have any questions about this, let me know, subscribe, and we'll catch you in the next problem.